Well, today is going to be hard. Maybe we start here. Let's just get in. Load parameters are some values we use to describe load, requests per second, read-write ratio, cache hits. Okay, that was good. A fault is when a specific component deviates from its spec. That was good. Throughput is the amount of work that can be done in a given amount of time, or the time it takes the system to work on a given amount of work. Job set, a job on a data set of a certain size. We'll say that was good. Impedance mismatch, when the data model of your application does not match the data model of your database. Although it's more generic than that, it's a mismatch in models in general. Between two layers, we should say. Yeah. What are the advantages of the document model? Locality, although increasingly not an advantage, really. Hierarchical structures, if that's helpful. Fast updates. No, slow updates. I can't remember. It's schemaless and flexible, often uses JSON or XML, allows nested structures, good for data that naturally fits into documents, and useful when one document corresponds to one object or entity in the code. What is a data model and why is it important? It's the data model is how we structure the data. That's probably over some. It's a stupid. It's probably more like. I can't remember why it's important. Is because it frames our method of thinking. It frames the method of thinking. Wow, I cannot, dude. I'm fried from today, dude. Ugh. I don't know. Like I know this, and it's like I don't know. Normalization is getting rid of duplication. Yeah. When is the document model a better choice? When your applications model reflects that of like a single object. It's like resumes. Fuck. What are the three primary data models discussed in chapter 2. Let's get rid of this card. But it's document, relational, and graph. Whatever. Let's just delete that one. What are the key characteristics of the relational model? Rows of tuples, joins, easier updates, structured data with schemas, tables, and foreign keys, uses SQL for querying, enforces normalization and strong consistency. Hard. Polyglot persistence is the concept of using both document and relational models to fulfill your application needs. What are the downsides of imperative queries embedded in application code? So first off, imperative is when you don't tell the computer, well, let's not define it by what it's not. Imperative queries are telling whatever what you need, but not how to get it. Oh, and then application code. Yeah. Business logic, harder to optimize and more error prone. So let's get rid of data models. This one can go away. It's not worth much. Alright, we did those. There was something else. Someone had commented. Let me see real quick. Let's see. Settings. General. How does this work? Appearance. The theme is typewriter. Looks like the theme. is going on here? All right, good enough. All right, back to it. Declarative queries. A web browser. Oh yeah, it's talking about how CSS is a declarative imperative language, since we declare patterns rather than the steps to find them. Yeah. If you were using XSL instead of CSS, you could do something similar. JavaScript imperatively sets the elements p sharks to have blue background, but the code is awful. Subjective. Not only is it much longer and harder to understand than the CSS and XSL equivalents, but it also has some serious problems. If the selected class is removed because the user clicks a different page, the blue color won't be removed, even if the code is rerun, and so the item will remain highlighted until the entire page is reloaded. With CSS, the browser automatically detects when the li selected p rule no longer applies and removes the blue background. If you want to take advantage of a new API, such as document.getElementsByClassName, or even document.evaluate, which may improve performance, you have to rewrite the code. On the other hand, browser vendors can improve the performance of CSS and XPath without breaking compatibility. Yeah. In a web browser using declarative CSS styling. So basically, it's backwards compatible. No, that's not correct to say. It's not backwards compatible, it's just an abstraction. Let's add a note here, I guess. there is a lot of happens that we don't have to declare. Cool. Now produce. Is a programming model for processing large amounts of data in bulk across many machines, popularized by Google. A limited form of MapReduce is supported by some NoSQL data stores, including MongoDB and CouchDB. It has a mechanism for performing read-only queries across many documents. MapReduce, in general, is described in more detail in Chapter 10. For now, we'll just briefly discuss MongoDB's use of the model. MapReduce is neither a declarative query language nor a fully imperative query API, but somewhere in between. The logic of the query is expressed with snippets of code, which are called repeatedly by the processing framework. It is based on the map, also known as collect or reduce, and known as fold or inject functions that exist. To give an example, imagine you're a marine biologist. I just zoned out. Oh. The logic of the query is expressed with snippets of code, which are called repeatedly by the processing framework. It is based on the map, also known as collect. To give an example, imagine you are a marine biologist and you add an observation records to the database. Every time you see animals, they add a data trunk. The query first filters the observations to only show species in the shark's family, then groups the observations by the calendar month in which they occurred, and finally adds up the number of animals in all observations that month. The same can be expressed in MongoDB's map feature. The filter to consider only shark species can be specified declaratively. This is a MongoDB specific extension to MapReduce. The JavaScript function map is called once for every document. There must be pure functions, which means they only use the data that is passed to them as input. They cannot perform additional database queries, and they must not have any side effects. These restrictions allow the database to run the functions anywhere, in any order, and rerun them on failure. However, they are nevertheless powerful. They can parse strings, call library functions, perform calculations, and more. Programming language, programming model. For distributed execution on a cluster of machines. Higher level query languages like SQL can be implemented as a pipeline of MapReduce operators. But there are also many distributed implementations of SQL that don't use MapReduce. Note there is nothing in SQL that constrains it to running on a single machine, and MapReduce doesn't have a monopoly on distributed query execution. Being able to use JavaScript code in the middle of a query is a great feature for advanced queries, but it's not limited to MapReduce. Some SQL databases can be extended with JavaScript functions too. A usability problem with MapReduce is that you have to write two carefully coordinated JavaScript functions, which is often harder than writing a single query. Moreover, a declarative query language offers more opportunities for a query optimizer to improve the aggregation pipeline. Match family sharks, group them by the year and the month, and sum the animals. To be honest, I don't know what to write for this. So what did it talk about, right? MapReduce is a programming model. MapReduce. I don't know how to define this. For processing large amounts of data in bulk across many machines. Okay. Let's just rip that, right? Oops. That's probably Hmm. I see. The cons is to run snippets of code on each piece of data. Is that? I don't know if that's really. Which are called repeatedly by the processing framework. Okay. And then basically survive long enough as a document model. You, what is it? There. Graph-like data models. Ugh, God, I don't want to learn about this. We saw earlier that many-to-many relationships are an important distinguishing feature. Oh my God, there's so much here still. Oh. Bro, what? Still have like 20 something pages. I just want to get to something new, you know? Well, the fastest way to do that is to keep going. We saw earlier that many-to-many relationships are an important distinguishing feature between different data models. Many kinds of data can be modeled as a graph. Typical examples include social graphs, the web graph, road or rail networks. It feels like this is missing. Hmm. so is that backwards? Why would starting not be head? can think of a graph store as consisting of two relational tables, one for vertices and one for edges, as shown in example 2.2. The head and tail vertex are stored for each edge. If you want the set of incoming or outgoing edges for a vertex, you can query the edges table by head vertex or tail vertex, respectively. Some important aspects of this model, let's see. Ooh. It's raining. I zoned out. Some important aspects of this model are any vertex can have an edge connecting it with any other vertex. There is no schema that restricts which kind of things can or cannot be associated. Given any vertex, you can efficiently find both its incoming and outgoing edges, and thus traverse the graph, i.e. follow a path through a chain of vertices, both forward and backwards, By using different labels for different kinds of relationships, you can store several different kinds of information in a single graph while still maintaining a clean data model. Those features give graphs a great deal of flexibility for data modeling, as illustrated in figure 2.25. The figure shows a few things that would be difficult to express in a traditional relational schema, such as different kinds of regional structures in different countries. France has departments and regions, whereas the US has counties and states. Quirks of history, such as country within a country, ignoring for now the intricacies of sovereign states and nations, and varying granularity of data, whereas her place of birth is specified only at the level of the state. You can imagine extending the graph to also include many other facts about Lucy and Alan for other people. For instance, you could use it to indicate any food allergies they have, sure, and links allergens to diversities. And you could write a query to find out what is safe for each person to eat. Graphs are good for evolvability as you add features to your application. A graph extend to accommodate changes to your application's data structures. Interesting. So 30 seconds, nice. So I'll probably stop there. The next section is Cipher query language. I don't know how relevant this stuff will be. I might not take notes on some of this. Like, I'm never gonna remember, and I also don't feel the need to remember anything about the Cipher query language, other than that it exists, maybe, because I don't work with graphs. But anyway, another time.